warm welcome to the NXP sponsored seminar for Introduction to nxpUSBlib. My name is Amit Bojraj. I'm the Product Marketing Manager for the Cortex-M0 line. So today our objective is to give you a 1-hour introduction to nxpUSBlib. And the plan is to quickly go over the NXP USB portfolio, followed by a demo showing how the out-of-the-box experience is going to be with NXP USBlib. And then our plan is to kind of go over 3 areas. So what is NXP USBlib, how to use the software package, and why would you want to use it. And then finally, we're going to do a quick summary about the whole presentation. And the way it's been broken up, I will do of course, a marketing pitch for a quick 10 minutes, and then the real deal begins with Dale coming on board, talking about the out-of-the-box experience, followed by Paul's session where he talks about how to use NXP USBlib and why to use NXP USBlib. All right, so here's a brief introduction to the NXP USB portfolio. So our strategy is very straightforward and very simple. It is 100% focused towards ARM. If I go back in time to 2002, when I first joined the company as an intern, the very first project I worked on was the validation of the very first ARM7 device from this team. It was the LPC11U00 an ARM7 based core. And in 2003, I think we launched 3 parts in the market. If we now go down the lane, what is it, like 7 years, we have over 250 parts in the market today. And I can confidently say that we are the market-leading vendor when it comes to ARM-based solutions. So from ARM7, we made our switch to ARM9, and from there, we made our way into the Cortex-M platform. So that's where we are today. That we see Cortex-M0, Cortex-M3, and Cortex-M4 as our 3 main lines focusing on MCU solutions. And what you see in the background is how these 3 lines map across the traditional boundaries of the MCU space that you may be aware of. That's what you see on the background. There's 8-bit, 16-bit, 32-bit, and DSP. So we believe that the M0 platform is a true replacement for 8 and 16-bit. And we'll talk about that in a bit in the next subsequent slides. Cortex-M3 is where we are pushing the bar on performance. And we're also bringing in more communication peripherals, more integration into a single chip solution. And then finally, we have Cortex-M4, which focuses on the advanced digital signal control. And we also bring in a dual core solution with M4. So we have an M0 and an M4 on the same chip. So M0 is our low-powered, low-cost platform. So as you can see, the pricing starts at 49 cents. When we came to the market with M0, we came in at 65 cents at 10K quantities distribution. And just last year, we have brought down the pricing again to 49 cents. We also brought in packages which were kind of the home ground for 8 and 16-bit. The TSSOP28s, the DIP28, the SO packages, which were kind of very familiar ground for 8 and 16-bit processors, was also brought into M0. So you will see a lot of familiarity when you go from a traditional 8 and 16-bit application to an M0 application. I think M4 is where we really bring in a lot of innovation. The dual core implementation was a first from NXP. Also, we brought in a lot more innovation in terms of the peripherals. So we have something called as a QSPI, a quad flash interface. As you can imagine, quad SPI flashes are becoming very popular and very cheap. So having a QSPI interface on board would be very beneficial. We also have something called as a serial GPIO, SGPIO, which enables you to emulate an I2S, for example, or a UART or an I2C. So it gives the flexibility of adding more peripherals on the fly. So yeah, that's where we are today with over 250 products in the market. I think we are in a very good shape when it comes to ARM-based solutions. We are also the leading vendor now for Cortex-M0 Plus, as you may have heard. So ARM did a press release a couple of weeks back, right before, I think, Embedded World, talking about the Cortex-M0 Plus. So that's going to be the new platform coming in to that 8 and 16-bit space, and we are the leading vendor in that in that arena along with the Freescale. Okay, so let's look at the USB roadmap for Cortex-M0. What you see here is the LPC11U family. So we have LPC11U1X, 11U2X, and 11U3X, followed by the LPC134X. So if you look at the 11U1X, it's our low-cost platform. So what is low cost? The starting price for this part is 99 cents at 10K quantities distribution. So what do you get for that price point? You get you get, in terms of flash configurations, you can see a scale up to 32K of flash. You see up to 6K of SRAM, and it's our platform for LPCXpresso. Then we have LPC11U2X, which increases the SRAM configuration from 6K to 10K, and it also brings in more integration with the 4K E2 block. We also have brought in a 64-pin package offering with the solution. Then the 11U3X, or what we see there as 11UXX, is just the extension of the 11U2X family, and it increases your flash from 32K to 128. And finally, we have the LPC134X, which is our Cortex-M3 solution. So that is a pin-to-pin compatible solution with our 11U series. So if you start your application today with the 11U100, and at some point down the road you hit the ceiling in terms of performance, there will be an option for you to just do a drop-in replacement with the LPC134X. And it gives you up to 64K of flash, 10K of SRAM, up to 4K of E2. Small sector sizes. Traditionally, if you look at our parts, like the ARM7 parts, to erase a sector, you have to do a complete 4K erase and then write. But now you even have the option of doing a smaller block, which is 256 bytes. So you kind of can do E2 emulation with the on-chip flash. So that's how it's kind of panned out. So we have the 11U series and the 134X, pin-to-pin compatible. Okay, so here is the roadmap or the positioning of our high-speed interface. So we have the LPC1800 on the bottom here, which is our Cortex-M3, and then we have our Cortex-M4 LPC4300. So it's not very clear, but if you can see the block diagram a bit more closely, we have the Cortex-M4 and the M0 coexisting on the same chip. If you look at the peripheral set, you will see like 2 CAN interfaces, 2 high-speed dual-host controllers. So that's something very unique about these solutions. We have not just device, or not just host, but we also have dual-host solutions with our portfolio. Followed by the typical suspects that you look at the SSPs, the I2S, and the I2C interfaces. So here is the block diagram of the LPC11U00, and that is something you'll be taking home today at the end of the session. So we're giving out the LPC11U14 boards at the end of the session as a giveaway. And what you see in the chip is what you see on the slide here. So it's a Cortex-M0 core running at 50 megahertz. In terms of GPIO, you have the option of up to 40 GPIOs in an LQFP package. We also have a TFPGA48, so 4.5 by 4.5 millimeters, pretty small. And then in terms of flash, you have 16K, 24K, 32K, up to 6K of SRAM, and then the ROM. 2 SSPs, I2S, USB, USART, and the ADC. This part has been certified by USB.org, which basically means that if you go to USB.org and type in LPC11U14, you should see this listed on the website. The next version about this has USB drivers in ROM, which makes it exciting, especially in the code space, especially in situations where you have constraints on the code space. So the ROM has got drivers for HID, mass storage class, CDC, and you also have the option of doing your own custom class. So that's where you have big savings. You can get up to 4 to 5K of code space savings in your on-chip flash. and which is kind of critical for these kind of applications because you only have, what, 16K, 24K, or 32K of flash. So there's an option for you. And it's an optional element. If you don't want to use it, you don't have to use it. But it's there for you as a bonus feature. Okay, so here's where I hand off the podium to Dale.
Today we're going to take a quick look at USB host example running on our High-Tex board with a LPC1850 on it. This chip has 2 USB controllers, and I'm going to be using an LPCXpresso board that's been cut in half. So what Paul did was he pointed me to all the library modules, select them. I'm going to bring them in. I'm going to wait. Ah, there it goes. Now, what I'm doing is I'm running on USBlib now. USBlib supports all of NXP's microcontrollers that have USB blocks in it, except for just a couple, and all the Cortex ones. We're going to have ARM7 and ARM9 soon. And it does it with one set of code. So the examples that I'm going to show you here don't have to change from platform to platform. The library, what you do is you select a board that you want to run the example on. We support these boards right now, and there's more boards coming. That's quite a good list. I'm going to select the LPC1850 High-Tex A4. This is the newest board from High-Tex. I'm going to select, the CDL means Common Driver Library. So I'm going to select the drivers for the chip that I'm on. I'm on an LPC1800 right now, 1850. I'm going to go to the library, and I'm going to configure it to run on the USB controller that's in that chip. I'm going to tell it to run in host mode. And then I'm going to configure the application and tell it which chip I'm running on. And there's one extra step in this tool. You have to go down and tell the tool which core you're actually building for. And in this case, it has to be 1850. Now, in the past, I have not had to set the MCU for the other libraries, but we'll see. I could be wrong here, but I think it's going to work. I think because by default it's set to an M3. That's why I don't have to do anything. And then I go to the quick settings, the quick start, and I build it. And it's building the libraries. Now, nxpUSBlib is not a true library. It's not a binary library. It's source. You get source for every single bit of software that you see we're building here today. Everything. There's no binaries at all. Nothing's hidden. The support for all the different chips, the support for the different USB stuff is built into the code. Okay, there we go. So hit the play button, and I'm debugging. Now, there's the diagnostics. There's some diagnostics in all the host code, so you know that it's actually running. Here's the line of code in the example that produced this string that you're looking at right here. All right. Now, the board support package contains the code that drives the serial ports for all the different boards. So we have this one function, and it goes through the BSP, and if I selected a BSP for a different board, it would configure that differently, but you'd still get a string out on a serial port. Okay, so now I'm going to plug in a flash drive, and it'll say that its device is attached, and it'll dump out the contents of the first sector. What is USBlib? You just saw it. USBlib is, well, let's just talk about the APIs real quick. It's very simple. The application calls USB init to initialize it, get it going. Calls connect to connect it to the bus. And then there's a series of event functions that you fill out. And all these event functions are things, for instance, in this case, like device attached, device unattached. There are a series of event functions that any USB core is going to want to call, and you have to fill out information to respond to that particular event. In this case, I added a little piece of code that said device attached in an event function called device connected. All right, so there's another event function for reading and writing sectors, that sort of a thing. Okay. So USB ROM drivers. This is a block diagram. This is what it basically looks like. And like I said, some of our parts have USB ROM drivers in them. It's a good idea to use them. It saves space that you would otherwise like to use for your programs. So we encourage you to use them. And in fact, USBlib actually works with them nicely. All you have to do is set one little switch in the library, and it'll revert to using these drivers instead of using its own drivers. Savings up to 4K, actually that's wrong. It's savings up to about 7K of space. They're only for device mode, though. We don't have them for host mode right now. But USBlib does have host mode code in it, so the library itself covers everything you need. All right. So this is what you get when you use USBlib in conjunction with ROM drivers. Let's say that the board that you're taking home today does not have ROM drivers. You want to write a little program, a little application or something, get it running on this board. If you decide to move over to the 11U2X or 3X or the 13XX or 18 or 43XX, those all have ROM drivers, then you don't have to change a single line of your application. You just flip this one switch, which I think it's in the next, okay, it's further down, there's a slide. You set this one definition to a 1, and USBlib turns into a very, very thin pass-through API layer. So all of the code in the library goes away, and it simply redirects itself and calls right into the drivers, the ROM drivers. Now, you don't have to use USBlib to talk to the ROM drivers. The ROM drivers are all accessible by starting with this one memory location that has a pointer into a table, and the table has pointers into all the functions of the ROM drivers. And you can set up structures and do all this stuff to make the ROM drivers work. But if you use USBlib, it does all that stuff for you. And more importantly, if you move to one that doesn't have ROM drivers, nothing changes other than the amount of memory that you have to use to run it. So same API application interface with or without on-chip ROM drivers. So the library supports host and device mode, and very soon it's going to be supporting dual host. So one library will be able to drive both USB controllers that are on the 18XX and 43XX parts. It'll be able to drive 2 hosts or 2 devices, or 1 host and 1 device. We'll just enumerate in the library. We'll just say, do something with USB 0 or USB 1. Class support. We support all these classes except for DFU and Smart Card. DFU is coming pretty quickly, Smart Card soon after that. So what's included in USBlib? So it supports full and high-speed controllers, all transfer types. It supports multiple tool chains, 2 right now, and we will have IAR supported probably hopefully in the next couple of months. And I'm thinking of also supporting Rally as well. There's a list of boards that we support right now. We're probably going to support a few more than this. If you want to, the best thing to do obviously is pick the board that's closest to the application you want to build and use that as a template. So we're going to try to get as many boards from a wide different range of applications as we can to support. And the examples, there's a total of, I think, 9 or 10 examples. They're listed there, and a couple more are coming. and of course, support for ROM drivers. And again, every bit of this is in source, except for the ROM drivers, of course. Where to get it? This is, you go to the link on this page. After, a couple of weeks after the show, the video and the slideshow will be available. So you don't have to write this down if you don't want to right now, but it's really easy to remember. Just remember lpcware.com. That's the starting point for everything. And there's a forum in there. There's links to lots of different documentation, user's manual, data sheets, example code, and this library as well as other libraries. This particular website will take you through all the steps that you need to get USBlib. Has anybody visited this website? Anybody in this room been to this website? There's one good guy. Okay, so it's very, very simple. There's a page called Get It where it'll explain how to get the software, where to go get boards, where to get the tools. It'll have pictures of all these products with links to them, to how to get to them. And there's a Build It page that explains how to set up the tools and how to actually build the library. And then there's a Use It page, which has the license information. And there's a license that comes with USBlib. It is free to use any way you want, as long as you're using on NXP processors. So almost no license. Okay, so when you get USBlib, you get one zip file, and this is all the things that it contains. So it's got the full stack, the applications. There's an Android accessory project. The Android accessory project that's in this library is run at our booth today. If you go over there to the Cortex-M3 table, we have an Android phone there talking to it, and it's that project that's actually running and talking to that phone. There's a few other projects that you can get for this example from Embedded Artist. It runs on phones and Zoom tablets. All right, and you can get the board itself from Embedded Artist, or you can run it on a 1768 or 69 Expresso board with a baseboard. So you get projects, project files, documentation. We also have Doxygen documentation online on the release notes page on USBlib. So it's just Doxygen right online. This is the directory structure in the zip file that you download. Okay, so two main folders. You have an applications folder and a libraries. The libraries, there's probably no need to, you're probably not going to find yourself in there unless you really want to do much, at least not in the USBlib and the CDL. The CDL, by the way, is the CMSys drivers for the different chips. This platform is going to be changing soon. We're going to be including CDL or chip libraries for all of our microcontrollers, ARM7, ARM9, all the Cortexes, and we're going to merge them all together into a unified driver library. And it's going to support everything that we do with a single API, which makes things nice and simple and easy. And all the libraries, this is not the only one. We're going to put the graphics library up there, the networking library, FreeRTOS, and a few other things. They're all going to be on the platform, all talking to the same set of drivers, talking with each other. Every one of them configurable for any processor and any compiler, well, 4 compilers, and any board you like, as long as it's one of our boards in the board support package. The board support package, the BSP library, that's the area that you're going to want to work on when you want to port it to your board. You don't have to use the board support package. You can just as easily just chop it out and not use it, or you can use one of the BSP files that we have here as a template for your board. Okay? The BSP gives you a common unified API for things like, set GPIO, LEDs, UART, initialization, get, put character, things like that. The application section, these are all the examples. And, if you're like me, you're going to want to just pick the example that's closest to your application and start there. Projects, the projects, excuse me, projects are examples that use, that are not necessarily, specifically examples for classes, but outside of that realm. Kiosk is a partially completed example that uses our SWIM graphics, excuse me, our SWIM graphics library as well as the USB library. Okay, so building it in Kyle, both Kyle and LPCXpresso have build configurations. In Kyle, they're called targets. And in Kyle, since we have multiple libraries, and since the examples link those libraries in, you're probably best to use batch build feature. In Kyle, has anybody used that before? Nobody knows what that is? Basically, it allows you to have multiple projects, and it applies dependencies to those projects so that you can tell it to build, build a BSP with this configuration, a CDL with this one, and it'll build the libraries, and then it'll build the application and link it all together. Okay. In LPCXpresso, it's basically the process that I just went through earlier. And you can get this slideshow if you like later and reference it, or just read the manuals for the tools, or go to the Build It page on USBlib, on NXP USBlib website. This is where this is the definition that I was talking about that decides whether the stack is working with ROM drivers or not. So all you need to do is set that from a 0 to a 1, and it'll start using ROM drivers. It's not a runtime thing; it's a compile time thing. Force full speed. That's just there so that when you run the, we have an audio out example that drives USB speakers, and USB speakers are full speed devices. So this forces the high-speed USB controllers to run in full-speed mode. Okay? And now I'm going to turn it over to Paul, who is not very familiar with it, and I asked him to do a project and see how long it took for him to do it. So he'll give you his experience.
Okay, so here are the board support packages that are currently supported within the NXP USBlib. For this project, I decided to use something that's not in the board support package. I'll be using an NGX-based board. Okay, so for this project, we're going to be a very simple project where we're going to turn an LED on and off. So we're going to write 1 byte, and we're going to read 1 byte back to get the state of a switch. So the switch will report a 1 when it's not pressed and 0 when it is pressed. Okay, so pretty simple. But again, it's starting from scratch. I had not even seen this package before I started this exercise. Okay? So first step is we're going to do the same exercise that Dale did. I'm going to take out all the stuff that Dale had in his. And I'm going to pull in my example. Rather than pulling in everything that he did, I'll do it a little differently. I'm not going to pull in a BSP because, again, it's so simple what we're doing. We don't need a BSP. So again, two ways to do it. You can modify a BSP that we already have in there, use that as a template, or create your own, or just not use one like I'm going to do here if you have something really simple. So what are we going to use? We're going to use common driver library. We're going to use the generic HID example. And we're going to need NXP USBlib. We're going to pull those in. Okay, like Dale did, you set the active build configuration, build on the 11U, and again, that's what you're going to get today at the end of the session, the LPC11U00 I'm going to do this for all the different projects. Dale says I don't need to do this, but I do it anyway. I'm going to set the MCU for each of the projects to the LPC11U. Okay, so when I'm more confident, I'll try it without changing all three. Okay, one more thing to check is the indexer. And just to make sure that it's going to use the active build configuration and it wasn't selected there, so we're going to select it. Okay, so one thing I want to do is, since we're not using the BSP, I can get rid of that. I'm not going to use the BSP library, so I don't want it looking for that. So I'm going to take that out of there. Okay, so that's the basic setup of the project. So now we're going to start getting into the guts of the project. Okay, first thing we're going to do is we're going to say how many bytes in or out. Okay, so a HID uses reports, right? So when you say reports, that is the size of the data that you're sending. So here we're just going to send 1 byte. Okay. Actually, let's go here. I'm going to get rid of this bsp.h. I don't want to reference that. And here's where all the action is in the generic hid.c file. Okay, so these are where all the calls are. One thing I'm going to do is include, since again we don't have a BSP, so we're going to directly use the LPC11U XX header file. All right. Yep. Okay. We have a lot of stuff in here, LEDs, because of the board spare packages. So I'm going to take all of those out. We don't need this SEI. Next step, BSP, we're not using a BSP, so we don't need the unit. We're not using the LEDs from the BSP, so I'm going to take that out.
So we're supposed to believe that you're a marketing guy that's never done.
I'm an FAE. So that's a halfway between these two guys. Okay, so here's the important stuff. Create HID report. So what's create a HID report? So you're creating a HID report. That means you're sending something back to the host, right? Because everything is referenced to the host. So if you're creating the report, that means you're sending it back to the host. So here what we're going to do, I'm going to cheat here and take it out of the presentation, which you'll have access to. Okay, so create HID report. All we're doing is taking a look at GPIO 0.1, as we said, and seeing if it's high or low. So I'm going to copy that and put it in here. Okay. And for the process HID report, that again, you're going to process a report that's sent by the host. Again, due to time constraints, we'll do a copy and paste. So what's this actually doing? So what it's doing is it's taking a look at that byte. So data 0, it's ending it with 1, seeing if that bit is a 0. And the next function is kind of interesting because what it allows you to do is we said, okay, port 0.7 is going to drive an LED. So what we can do is use a register in the GPIO domain that says set this particular bit or particular bits. It's kind of like bit banding, but it's actually a lot easier to use. So this register allows you to set particular bits. So if it's a 1, if I'm sending a 1, the LED is going to turn on. And if it's off, I'm going to clear that bit. So I have another function called that. It's just clear 0. That's what's 0 in parentheses 0. That's port 0.7. That's what that one shift. So everyone understand that part fairly straightforward. Now, one thing I still need to do is when the part is initialized at reset, all the port pins are inputs. So what I need to do is I have to set the port 7, 0.7, as an output, right? Okay, so setting a 1 in that position sets it at that particular port pin as an output. Now, did I forget anything? I changed the descriptor to 1. Yep.
The compiler will tell you what you forgot.
Yeah, the compiler will tell me what I did wrong. Okay, so now I'm just going to build this thing. Okay, let's see. No fault. Okay. Simple HID. As you can see, we already have one on there. That's the debugger, because I haven't plugged in the device yet. Okay. So here, it knows right away. Okay, it's 1 byte. Report 0 is default. And what I'm going to do is hopefully when I press the write, it didn't work. Oh, writing a 0, that's why. Make that a 1, Paul. The light's on. And then 0, write, and it's off again. Okay, and then we have a switch, right? I'm going to read it, and it's high, as we expected, and now I press it, and it's low. Okay. So easy. Even if FAE can do it. Okay, so let's look at a comparison. So a stack that a lot of people are familiar with is Kyle. I mean, Kyle's got a great USB stack. We used it a lot in our example code. And you can see that NXP USBlib is very close in code size to the Kyle. However, if you use a device with the ROM code drivers, it's about 50%. So you have significant savings by using the device with the ROM code drivers. Now, we also made a comparison with USB Host Lite. We have a package called USB Host Lite, which was developed several years ago. And it's a package that it's a host that only supports mass storage. So it's very limited, but it gets you started. So we compared it with that, and as you can see, NXP USBlib is a little bit bigger, but it's got a lot more functionality. It doesn't have the same limitations as far as just supporting mass storage. So I think it compares very well with that. Okay, so as far as support, I would recommend going to LPCware. Dale has already mentioned this. This is where you'll get NXP USBlib as well as several other things like MWin and our peripheral driver libraries and things like that. Within LPCware, you'll see the forums. And these forums are actually monitored by people within NXP. And we want to hear from you. So if any kind of errors that you find, any limitations, certainly go onto the forums. And again, it's monitored by us, so we can certainly address any of those issues. So I'm going to hand it back to Amit for summary.
Thanks, Paul. Thanks, Dale. So going back to this particular page here, I need full screen. So going back to this page here, I think the LPCware community is really exciting for our customers. We built this website to connect with the engineering community. So that was the whole idea, because we have a marketing portal called LPC Zone, and we said, no, we don't want to pollute the two areas. We keep them separate. We have the marketing portal, and then we have the engineering portal. And LPCware is that solution. As you can see, the idea for the support is not an email-based solution where you send an email to an address and then someone emails you back. But it's a very open platform. It's on a forum, and we highly encourage you to get on the forum and post your inputs. So as a summary, what I would like to say is NXP USBlib is a free software package, and there is no, yesterday when we were doing the seminar, someone asked us, hey, is there any licensing loopholes that we have to worry about? The only thing that you have to remember is that this package can only be used with NXP MCUs. That's pretty much it. Otherwise, you get the full source code. It supports 6 classes almost right now with HID, mass storage, the audio classes. As you can see, we also have support for the On-Chip ROM drivers, full BSP support for a variety of solutions, and then device host, and we're also working on dual host. So it's not just a free package that we want to give out to hook on our customers. It's actually, we're spending a lot of effort to get this to the professional level where it I think it already is. Our plan is to make this a one-stop shop for USB, not just in terms of the software, but also in terms of the hardware. So as you can see now, we have the widest range of ARM-based USB MCUs, from full speed to high-speed solutions, device host, and even dual host controllers. We try our best to get these parts certified at usb.org so that you have the peace of mind that these parts will function as per the USB spec. NXP USBlib is one additional effort that we are doing to get the software all ready for you and reduce your time to market as you go to production. The On-Chip ROM drivers, as I see it, is a bonus feature that comes with almost all our USB parts. You get the flexibility of using HID, mass storage, CDC, or even a custom class. This also allows you to do programming via USB. So if you enumerate our evaluation board has a mass storage class, it will show up on the PC as a drive. So your flash, your 32K of flash, maps to the PC as a drive. And to update the firmware, you just do a simple drag and drop, and that's pretty much it. We're also very close to launching a free USB VID PID program. So we'll be launching a program which will allow you to use the NXP PID, and we'll be offering, VID, and we'll be offering up to 3 PIDs per customer. So it's going to be launched very soon, and actually it's going to be launched this week on LPCware. So if you go to lpcware.com and just look for NXP USBlib, you will see the PID program right below NXP USBlib. And that's pretty much it. This is our last slide, which talks about how to get started. We have the NXP home page, of course. LPCXpresso is one platform where you can check out our latest and greatest IDE. And then finally, I would say, yes, LPCware is where you'll find everything that you need to know about NXP USBlib and all our other software packages, including our LCD and our motor control solutions. So that brings us to the end of the presentation. Thanks for your attention.